Hi everyone, this is Babaiah, Assistant Professor of EC Department from MLR Hyderabad. Today I am going to explain about the signal flow graph and its some basic elements. See here, previously we discussed about the block diagram reduction rules, and based on that rules we are going to solve some problems also. Now we are going to learn some signal flow graph and what are the basic elements are available in the signal flow graph. Now we are going to learn. Next, coming to here, what are the outlines of today lecture? Here, observe introduction to the signal flow graph and definition of that signal flow graph. What are the basic elements or terminologies are available? What are the example of this SFG or signal flow graph? Now coming to the introduction to the signal flow graph, the alternative method of block diagram representation developed by the Samuel Jeffers Mason or SJ Mason. We call it as, directly as SJ Mason. What are the advantage? The introduction to signal flow graph. What are the advantage? What is the definition? What is the basic advantage compared to the block diagram reduction? Here just the availability of the flow graph gain formula or Mason's gain formula, that is we call it as the Mason's gain formula. By using that formula we are going to calculate the transfer function. And here the signal flow graph consists of a network in which nodes are connected by directed branches. Nodes are connected here. Nodes are connected in directed branches. What are the nodes and branches? We learn the next. Here it depicts the flow of signals from one point to one point of a system to the another, and gives the relationship among the signals. The basic definition of the signal flow graph. The signal flow graph is a graphical representation of algebraic equations. What are the if we have any algebraic equations are there, by using that algebraic equations we are going to represent in the form of the graphically, then that function is known as the signal flow graph. Here signal flow graph is a graphical representation of algebraic equation. And here what are the fundamentals of signal flow graph? Here just we have a node is there. What are the fundamentals? Node, branch. What are the branches are in the which direction? Here see here every variable in signal flow graph is represented by a node. Represented by a node is small circle. This is nothing but the node, right? It is a node. Every variable in signal flow graph is represented by a node. Every transmission function in a signal flow graph, variable in the form of node, and transmission function in a signal flow graph is represented by branch. And also branches are always unidirectional. Branches are in the form of, or else which in the direction is unidirectional only. Here the arrows, branches just unidirection like this. Okay, now unidirection only. The arrow in the branch nodes. Here this is the arrow. For example, this is the one branch, and that arrows are denotes the, or arrows are on the branch denotes as the direction of the flow, signal flow, or direction of the signal flow. Signal flow is indicated by using the arrow on the branch. Okay, the arrow is in the branch denotes the direction of the signal flow graph. And coming to the what are the basic elements in the signal flow graph? Nodes and branches are the basic elements of the signal flow graphs. Nodes, branches, some of the elements also available in a signal flow graph. What is meant by node? Node is a point, or node is a variable. We can representing in the node is just a small circle, right? So node is a point which represent either a variable or else signal. To represent a variable or a signal. There are the three types of nodes are available. How many types? Three types of nodes are available: input node and output node and mixed node. What is mean by input node? It is a node which has only outgoing branches. If for example here one node is there, from this node the output branch or outgoing branches are available. From this node, we have only outgoing branches. Outgoing branches. So this is the input node. This is the input node. If any node consists as only outgoing branches, then we call it as the input node. And output node, it is a node which has only incoming branches. Here, like only incoming branches. Arrow, like this symbol, incoming branches. Incoming branches. This is the output node. And here any mixed node. Mixed node, it is also one of the node and which has both incoming as well as the outgoing branches. For example, one node I am going to consider here. This is the outgoing branch, and here this is the incoming branch. Outgoing branch, incoming branch. Outgoing branch, if any node has only outgoing branch, then that node is called as the input node. If any node has incoming branches are having, then that node is the outgoing branch. So here outgoing and incoming, all this. So these two branches are available at a particular node. So this node is known as the mixed node. This node is nothing but the mixed node. And here, if any signal is moving like any signal is moving like from here to here and from here to here, this signal is nothing but the mixed node. Mixed node, right? Here next coming to see here one example. Let us consider the given following signal flow graph. Identify the nodes and branches. Here just observe from the just these all are the, this one is node and this one is node, this one is node, all the four nodes we have. And this is nothing but the signal flow graphs. Arrow mark indicate the signal flow graph. And here this is nothing but from here to here node. Y1 to Y2 is the branch, and Y2 to Y3 is the branch, and Y3 to Y4, all these are the branches. Here observe, these nodes represented in this signal flow graph are Y1, Y2, Y3, Y4, all these are belongs to the nodes, and Y1 and Y4. Y1 and Y4, these two are the, Y1 is nothing but the input node, and Y2, Y4 is nothing but the output node, and Y2 and Y3, these two are the mixed node, because of here incoming as well as outgoing branches are there. So Y2 is the incoming or mixed node, and Y3 also mixed node we called it. Here from this example we observe node, branch, what are the input node, what are the output node, and mixed node, right? Here observe, branch is a line segment. Here branch is nothing but is a line segment which joining the two nodes. For example, Y1 to Y2, these two nodes joining a line segment is nothing but the branch. It has the both gain and also direction. It has the gain and direction. Both branch has a gain as well as the direction of the branch. For example, there are 4 branches in the above. Here observe 4 branches, 1, 2, 3 and 4. 4 branches are there. These branches have gains. The respected gains are A is the gain of this branch, gain of this branch is B, and gain of this branch is C, gain of this branch is minus D. All these 4 are the gains of the respected branches. Here next, forward path, any path from input node to output node without crossing a 2 nodes or else more than 2. Here just directly from first to forward path is nothing but the input node to output node. Input node to output node directly passing all through the nodes, that is nothing but the forward path. Here next observe loop. What is mean by loop? A closed path from a node to the same node. From node to the same node. Here just this is the example. Here just observe Here this one is the loop from here to here, starting from the y2 node and again moving to y3, again back to the y2. So this is the loop. So closed path. So closed path from a node to the same node is called the loop. Next, self load, a feedback loop that contains of only one node. Feedback loop contains, for example, here this is the same node, same, or else self load within the same, start and end at the same node. Here a feedback loop that contains only one node is called as the self load. And loop gains, the product of all the gain forming a loop, here just observe, this is the loop. So the product of these two gains, b and minus d, this is nothing but the b and minus d is nothing but the gain of that loop. Simply here gain of that loops. And path gain, here a path is the traversal of connected branches, here connected branches in the direction of branch arrow, just here observe, this is the path from here to here connected, and here to y2 to y3 connected, y3 to y4 to y5, y5 to y6 connected. This is the forward path. And here path, that is also one of the path. A path is a traversal of connected branches in the direction of branch arrow. Path gain, the product of, here see, path gain, the product of all branch gains while going through the forward path is called as a path gain. Here just observe, this is the one forward path, or else path is there, all the gains are going to be product of this path a b c, that is nothing but the gain of that path, just here gain of that path. Next, coming to the feedback path or loop, here just observe, loop is nothing but the closure, right? Here already we learned the closed path from a node to the same node is called as a loop. And here feedback path or loop, it is a path. Feedback path is nothing but a path to output node to the input node, see here observe, this is from here to here, y2 to y3, y3 to again y2. So output and input, for example, these two are connected. This is the loop, or feedback path. And touching loops, when two loops are common node are there, if any two loops, here just observe, this one is the this is the one loop, and from here to y3 to y4, y5, y5 to y3, this is one more loop, this one and this one, these two are touching. So touch loops, these two are nothing but the touching loop. When the loops are having the common node, that the loops are called as the touching loops. If non-touching loops are nothing but there is no common loop for the two loops, that is nothing but the non-touching loops. Opposite, just here non-touching loops, when the loops are not having any common node, between them, that are called as the non-touching loops. Here see, observe, y2 to y3 is the one loop, and y3, y4 and y5 is the one more loop. These two, observe these two, y2, y3 and y4, y5, these two are the two loops, but these two loops are not having the common node. This is the best example for the non-touching loops. For touching loops, this is the one loop, and this is from y3 to y5 to again here, these two compared to the common node is the y3, that is the touching loops. This is the example of non-touching loops. The basic here, just from this signal flow graph, just observe, all this. y1, y2 and y3, y4, y5 and y6. y1 to y2 and in means y1 to y2 pass y6 pass the signal through along the all the signals touching. So this is nothing but the forward path. And here one more forward path here, just observe, from here to and here again y5 to y6. For input to signal is started the input and ended the output. So that is the forward path. One more forward path is there. So here see again the self loop here, self loop, the same node, feed forward path or feedback loop will be at the same node. This is the example of self load, right? Here just observe what are the paths are available here. See y1, y2, y3, y4, y5, y6. This is the path. Just observe y2 to y3, y3 to y4, y5, y5 to again. This is the one example of path. And also one more is here y1, y2, y3 to y5. So y3, y5, y6. That is the one more path. Next here observe forward path. Forward path is nothing but the path that exists from the input node to the output node is known as the forward path. Previously we discussed. Here example y1, y2, y3, y4, y5, y6. This is the one forward path. And y1, y2, y3, y5, y6. Just observe the example of this one. y1, y2, y3. Again here y5, y5 to y6. This is the one more forward path. Next forward path gains. Just product of that forward path. Product of the gain of forward path is nothing but the forward path gain. Just multiply all the gains. Example here y1 to y3. Here observe y1 to y2, y3. A into B into C into D into E. This is the product or gain product. A, B, C, D is the forward path gain of y1 to y2, y2 to y3, y3 to y4 to 5 and 6. And A, B, G, E is the forward path of, just here observe, one more forward path, A, B, G and again come to here E. A, B, G and E, right? This is the one more forward path. This is the example of forward path. Next loop example. Here loop, this one is the loop and here this one also loop and here this one also loop. How many loops from the example? One loop and second loop, third loop. Signal start here y3 and pass to the y4 and again to the y5, again return back to the y3, feedback to the y3. So this is called as the loop. So we have a 3 loops are available and here one more self loop is there, right? These are the loops. And here non-touching loops, common there is no common node here, this loop and this loop, there is a no common node, non-touching simply. Next here so all these non-touching loops. If touching loops are available, here, see this one and these two touching. So these two are the touching loops. This is the basic or best example for consider the what are the loops are available, touching loops, forward path, and what are the gain of forward path, what is the self loop. All this we learn. Here just observe all the basic elements, loop, forward path, self loop, path gain, feedback path or loop, what are the touching loops, what are the non-touching loops. All these are we learn from the today's class. And what is the node? Node is a variable or signal. Just simply what is the branch? What are the nodes are available? Input node, output node and mixed node. These all are the basic elements of the control, basic elements of the signal flow graph. For the next class, from the we are going to learn the Mason's gain formula, right? Up to till today's class, we just what is the signal flow graph, what is the representation of signal flow graph in the form of graphical representation, what are the nodes are available, means what are the basic elements are available in signal flow graph. So we learn from the today session, just we learn all these of elements. For the next class, we are going to learn the what is the Mason's gain formula and what are the problems based on that Mason's gain formula, right? So I think understood every point. These are the very important. By using this, we are going to solve some problems. So this is the very important for you. Thank you all.